All right, hello everyone. We're QuickLit. My name is Rex. This is my teammate Joy. So for our goal and motivation, the motivation is to cut down the manual grind of finding and skimming papers. Thus, our goal is to develop an agentic system that automates the literature retrieval, summarization, and understanding workflow, where retrieval ensures good coverage of the research topic. And second, some summaries extend beyond abstract and conclusions to provide richer synthesis. And lastly, an integrated RAG chatbot ensures user to interactively explore the literature. So we'll start with the demo. So as you can see, we have a pretty simple API. User can search with their inputs, and it will outputs at maximum right now 30 papers, and they can click on individual papers to get the abstract and the summaries. On the bottom right, there's the chatbot. The users can ask questions about all the papers that the users search for. For the data and labels, as you can see, we have 2 inputs and 2 outputs. So the first input will be the research topic. The output will be basically the papers with the titles, the abstract, and summary. The second input will be the answer to the question. The second input will be the user query to the chatbot. The output will be the answer to the questions.
So for the system architecture, the user can ask for papers, summaries, and chat responses. The backend coordinates a code rat storing paper chunks for RAG for the chatbot, OpenAI responses, which is responsible for finding papers, writing summaries, and organizing chat answers. And lastly, Archive API, which fetches paper data. So to evaluate our system, we have 3 metrics. First one, to evaluate if the papers found are relevant to the target topic, we compute the cosine similarity between papers, abstracts, and the target topic. To evaluate summary, we have LLM judge scores the summary on 4 dimensions: section coverage, precision, faithfulness, and writing quality.
So for evaluate the chatbot response, so we build a agentic judge. So it automatically grades the assistance chat about a paper using a fixed rubric. So the input to the agent prompt will be the full paper text plus the chat history plus the rubric. So the rubric is a structured list of criteria such as grounding, responsiveness, evidence, reasoning. Each criteria has a weight. Weight sums up to 1 and a 0 to 5 scoring guide. So this is the weight distribution that we use. As you can see, the grounding accuracy has the highest percentage because we think grounding accuracy should be the most important criteria. For example, here's one of the criteria we put into the system prompt. So it has the name, the weight, the focus tells the LLM what this criteria does, and the level, which tells the LLM how to judge it.
So let's see the results for each of the matrices. For the paper found, for example, this topic, we fetched 26 papers with mean and median cosine similarity both around 0.6, which falls within this reference range of relevant papers. For summary, we have this around 400-word summary by section for this paper, receiving an overall score of 9.
So for the chatbot response evaluation, so this is one of the example. The user topic is LLM usage in post-grad education, and there's a survey talking about this advantage and advantage. So the user is asking what are the disadvantages and advantages. So these are the example outputs of the results from the evaluation. So we can see one example is the evidence and citation. We get a score of 4 because the judge thinks we're kind of lacking the evidence, but we still have some citations in the response. So later we calculate the weighted score which is 4.85 in this case. And in general, the judge thinks it is still an excellent response.
So for an unsuccessful example of the result, this is for finding paper for the topic machine learning approaches and its technique. We can see the cosine similarity are pretty low, regardless the version of the prompt we tried. And we believe the reason was the topic was too broad and there is not strong semantic signal words, which result in weak embedding and low similarity. So what we learned is it's important to choose good matrix. And also we noticed for agentic system, the response could be slow and non-deterministic from times, which could be looking into in the future. And that's our presentation. Thank you.